Well, all right, here we are again. Astronomy Daily Live. It is 2 hours UTC. You can call me Cosmic. And hey, everybody! I am back. I'm back. Hey, I just noticed that Bobby just popped into the chat. Hey there, Bobby. Onto the panel. You're muted. I can unmute you if you want. There you are. I hear something.
Hey, I had something had like a major concern, but I'm okay right now. I just had to select it again.
Yay! Yay! So Bobby is on the panel, and the room is filling up as it normally does. So welcome everybody. Astronomy Daily Live. I'm back after the star party. So I've got the coffee here. Got the coffee, and I've got the. This is definitely hydrogen hydroxide, for sure. This is the nice calming HOH. It's that balance, right? There's an H over here, and an H over here, and the O is in the middle. So yeah, a nice balancing molecule. So cheers to that. So come on in, everybody. Join us in this ever-growing circle of friends, also called like the virtual porch.
I'd like to welcome Unicorn, Potato, and Tom Van Scott are in the chat.
Unicorn, Potato, I haven't seen you in a while. Hey, nice to see you in the chat. Nice to see you in the chat. So, yeah, I think it's been a little while since I've seen that name. Hope all is well. Things are good here. Just normal. So yesterday's live stream was canceled because I decided to do a little star party for coworkers and some friends and whatnot. And so yeah, last night. Hey there, Atta. Just getting to that now. So last night I packed everything up into the truck and went up to the location of my day job. Out where I am, there really isn't a bad sky. My day job though is in a little town, so there are lights, but the days when I sort of sweat that and am concerned are gone, right? I mean, I used to be really uptight about doing a star party and making sure that there's like no lights anywhere at all. And it's not that I've given in, it's just that I've realized that that's a very high expectation that can't be reached, which just sort of led to frustration, right? And it's like, no, this isn't about frustration. This is about having as much fun as we possibly can. So, thinking now is find the best.
Temptation.
What's that?
Do it well, temptation.
Yeah. No, best thing now is to just find the best spot one can, right? Which means, minimize everything. And like I said, even from the middle of this town, we can still see the Milky Way very, extremely easily. So I mean, it's not as if it was like, really, really bad or anything. It was extremely interesting, though, coming home, right? Because where I was, was sort of one set of conditions, and then I came home where it's dark, right? And after looking at the sky, for 2 or 3 hours, sort of get used to what that looks like. And I came home here, and I looked up, and it's like, wow, I am in a really dark spot because the sky was just, it was, I mean, it was almost completely different, right? I mean, exactly the same stars, but the background sky was just so much darker. Anyway, so got up there, set the telescope up, set up that one right there. Yeah, still got the bag on it. And set it up. Now, I opted tonight to just use the eyepieces. I didn't attach any kind of cameras or anything like that. It's like, you know what, I think either most of the people at this party had never really looked through a telescope at all. So my thing is, right, is that when you look through a telescope, right, those photons, right, are going into your eyes, right? They've traveled, like when you're looking at Saturn, right? Those photons, right, traveled from the sun all the way out to Saturn, some 1.2, 1.3 billion kilometers out, right? And then they've traveled most of the way back to go into your eye, right? So that's an amazing path, but in a certain sense, and in quite a real sense, right? Looking at an actual object, now, not a picture of an object, not like this, right? But looking at an actual object is a very, very, very subtle way of touching that object, right? So when you get your eyeball down on that scope and look at Saturn, you're in a form of physical contact with that body, and I think that's absolutely fabulous, right? And then you can extend that, right? You can look at galaxies, right, that are millions, maybe hundreds of millions of light years away, right? And 1 light year is about 6 trillion miles or so. So, you can look at some galaxy, the closest galaxy to us, right, is about 2.2 million light years away. So that's the closest one, right? So you can look at a galaxy at 10 million, 20 million, 100 million, 500 million with a big telescope. As they get further away, they get really, really, really faint, right? Really, really, really faint. So you need a bigger telescope most of the time, right? Either a bigger telescope or a longer exposure, right? I mean, if you're going to use a camera. But even, the combination of telescope size and exposure time can allow you to see, fainter and fainter, and to first order further and further away objects. So some telescopes these days, right, are looking back 10, 12 billion light years or so. JWST, the James Webb Space Telescope, is expected to be able to see objects as far as our physical limitations are, which is sort of when the, at least according to the story, right, when the universe sort of turned on, right, let there be light in a certain sense, which was somewhere around 13.3, 13.4 billion years ago. If you accept, the that story. You know, keep an open mind about that. You know, it is just a story. Um, do we have proof? Does the data match the models? Um, you know, are we pretty sure that this is how it's gone down? Yes, to all of those. And I just have to remind you, right, that we were pretty sure, you know, 500 years ago that the Earth was, you know, in the center of the universe and everything went around it. And our data matched our models and we were really, really sure and everything else. So just a reminder, you know, the humans have been wrong before. And you, despite what most of astronomy says, um, what they are giving you, what we are giving you, is just a story, right? It's just a story. We don't really know exactly what went down and who and when and why and where, and you know, we may never, and you know, you have to accept that, right? Science doesn't like to have questions that don't have answers, right? But so we build models, right? Um, and these models have various parameters, you know, that we can tweak and we can change to try to fit our observational data, which also has to be, you know, carefully acquired and carefully calibrated. There's all kinds of complications along the way. So, but anyway, as the story goes, right, uh, we we should be able to see light, right, about as far away as 13.3, 13.4 billion light years out. And the James
Now,
Webb.
going back to that star party, I guess as
Oh
if you
yeah,
do have beginners, I usually thought it's usually better if you don't bring your digital equipment, but wait until they get experience and then you start bringing your webcam, your CCTV camera, and look how much more wonders you can get. Maybe you get some data then.
yeah, and you know, sort of the point of a star party is to have fun. It's not really to, you know, collect data um, or anything else. So yeah, you know, my intent with these kinds of things are 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 to have as intimate a connection with the objects under observation that we possibly can. And for us here, that is looking at them, you know, with
Now,
your own eyes.
I'm on a couple of my church's singles group, and there were actually was one of them that says about how hypocritical guys are when they say "I love you," but they go with somebody else. It's like saying "I love you," but in real time you're saying "I love you," but sometimes you stake and then you just go with someone else.
Yeah, well, I think that goes for many humans, not just one particular half. I think, yeah, you know, mistakes can be made all the time, all the time. Anyway, so getting back to the star party, so I set up and definitely just using the eyepieces, and those would go right there, right right about there, right. So you know, oftentimes you have to you know, be able to you know, get into certain positions, right? You have to bend, or you have to squat, or you have to kneel, or you have to, you know, lean. It's never incredibly pleasant to
I guess
actually.
do get them started like that first. If you don't like that, then start with your webcam and your cameras.
Yeah, and you know, that's always an option. But like I said, you know, start parties are supposed to be fun. They're supposed to be, you know, trying to get as close to that thing as you possibly can. So yeah, set it up and did the star alignment. Super easy. Um,
Now, have you ever had any chance of redoing that mead again, or you just want to just chunk it?
Oh no, I'm going to do it again. I was sort of fighting two different things at the same time. Not really a fight. I was just trying. I was trying to do probably too much. So yeah, actually, probably maybe even tonight, I'll go out and try to do another star alignment. But I'm not going to live stream it. That's just that that's something that I don't necessarily want to worry about. I think once.
Yeah, I think it'd be better raw, but otherwise we're gonna see you like smashing it with a 2x4 and a hammer, sledgehammer.
Yes, yes. It may not be a telescope very much longer. So yeah. So yeah, I'm going to do that. And I need to understand why it wasn't actually able to do the star alignment that night, because I was doing everything right as far as I know, but I need to look at it a little bit more. But yeah, I'm probably going to pull that out in the next. Well, as I said, maybe even tonight. All right, so I'm going to keep going with my Star Party thing. Hey there, Crooked Ninja. Nice to see you in the chat. Just catching up to the chat now. All right. So set up, and I wanted to try to list the objects that we looked at. Let's see if I can remember them all. So we looked at Jupiter, and 3 of its moons were out. Io was actually behind the planet, so we just saw 3 of its moons. So we saw Jupiter, we saw Saturn, we saw Mars, and then I think we went to M13, the globular cluster up in Hercules. Looked at that one. There's another Messier globular cluster in that same area too, M92. So we looked at that. Where did we go after that? I'm trying to remember. I was going to try to do this in order, but I'm not going to remember exactly what we did. So, not in order. We looked at M6, M7. Both of those are open clusters down in sort of the Scorpius region. We looked at M22. That's a really big globular cluster down in Sagittarius. It was right next to Saturn. Actually, just east of Saturn, and then just west of Saturn are 2 nebulae. M8, the Lagoon Nebula, and M22, the Trifid Nebula. Now, I'm not exactly sure. I need to investigate this a little bit more, because I've recently sort of gotten some conflicting information. I'm not sure if the Messier object is the nebula itself, the nebulosity that's being, lit up by these stars, in the vicinity of this gas and dust, or if M8 is actually the cluster, the star cluster that is making the nebulosity glow. Not quite sure. The same thing goes for the Trifid. There's a cluster that makes that nebulosity glow, and I'm not quite sure if the Messier object is the nebulosity or the cluster. Not quite sure. That's something that. Yeah, I got some conflicting information about that the other day, and I need to check that out. Check that out for sure.
Now, out of curiosity, is Cascai really free, or you got some of them you gotta pay for?
Calsky?
Yeah.
I think it's free. I think it's free. I mean, you still have to, have a login, right? but and it's possible that if you don't have a login, there are some features that may not be like available, right? But I think for the most part, it's free as long as you create an account and all of that. Yeah.
Because I think one of the things I might do is like subscribe up to an email of amateur satellites that might be available. I like to try to get at least the voice satellites. I don't want to get like BPSK and stuff like that. I just try to get like the voice barriers like Jill's been doing.
Yeah, cool. Yeah, and that's actually one of the neat features about Cow Sky is when you create an account, you can actually have emails sent to you. I think it's done like every day. Or maybe you can set up the frequency, right? Set up every day, every week, every month, whatever it is.
Now, the way I've been doing radio satellite tracking is I let the G-Predict control my SDR software.
Right.
I think that's a nice feature you can have on a Linux-based system.
That is cool. That is very, very cool.
I think in Windows you can have a virtual communications port that also controls your SDR.
Sweet. So yeah, and you're using G-Predict?
Yes.
Yeah, I heard that one's pretty good.
Yeah.
Yeah, cool.
Orbitron, I think it's Orbitron's free for Windows. But Ham Radio Deluxe, I think you gotta pay for it.
I see. Yeah. Well, satellite orbits are very complicated, extremely complicated, and good models take into account all kinds of stuff, right? I mean, it takes the two-line element set, but then these what are they called? Ephemeris generators. They're very complicated. They have a model of the Earth that has all the mountains and all the bumps and all the model of the atmosphere. Just all kinds of stuff. It takes into account drag and all of that. So good satellite prediction software is vital, and I guess G-Predict is probably pretty good. It'd be interesting, to compare, when you start getting a signal compared to when like G-Predict says you should. Is it within a second? Is it within 10 seconds? Is it dead on? Don't know. Is there something wrong with the chat? Chat not working?
I think there's like not much people chatting.
Okay. No, I just saw the message from Tom.
Now, when I do my satellite tracking, if it's like way out or stuff, I wouldn't bother with it. But if it's like close to like the center, I would definitely not mind catching that instead.
Yeah, cool. Anyway, so going on with my star party. So we looked at M8, M20. Of course, we looked at M31, the Andromeda Galaxy. And we actually saw M32 also. And then I snuck a quick look at M110. So M110 and M32 are companion galaxies to the Andromeda Galaxy. So they're in the same area. So we did that, and then let's see. We looked at M57, the Ring Nebula. We looked at M27, the Dumbbell Nebula. Now those are two planetary nebulae, sort sort of what's happened there is that these stars have sort of come to the end of their lives, and at least as the story goes, these are sort of solar type stars, stars like our sun, about the same mass, about, well, basically the same mass, same size. And what's happened is their cores have collapsed, shrunk really, really fast. Well, that creates a shock wave outward that that blows the atmospheres of these stars, the outer shells of these stars, where there's still, mainly hydrogen and helium, and other trace elements too. It sort of blows it out in not necessarily a spherical thing, because you have to take into account, how the star is moving, how it's rotating, magnetic fields, electric fields, all of that. And so the shapes of planetary nebulae can be quite complicated. And so in both of those cases,
I think I want to may have a little problem with the chat. I think I should suggest her that she should refresh and stuff, because Uncle Bill Durham is here right now, and also was asking, a lot of those old folks where I live wants to see a close-up of the sun. I have a big solar filter for the front of the scope and a solar filter for a 2-inch 38mm eyepiece. Is that enough? Enough for the daytime?
Hold on one sec. I would although they're more expensive, I would highly recommend putting a filter on the front of the telescope, the big one, right, as opposed to a filter at the eyepiece. And the reason why is because this particular object, this particular astronomical object, is sort of a special case, right? It's sort of a special case. In that, when you take a large piece of optics, right, like what you've got, right, and collect all that sunlight and concentrate it to a point, what you're going to do is you're going to create a lot of heat, and if you put a filter right at the eyepiece, then you're passing that really, really hot, almost focused beam through, both the filter and through the eyepiece. Now your eyes will be protected. In fact, you probably won't notice the difference at all, depending on which way you go. But what a big one on the front does, right, is it never lets all that light in. Right, so there's no danger of melting, and I've seen that happen. I've seen that happen. Eyepieces catching on fire because, yeah, it's just the sun is.
I hope it doesn't melt your eyes out, though. That's gonna suck.
You have to be extremely, extremely careful, and that's why I recommend, at least, blocking on the front. I'm getting a hole here. So kind of hard to see with the bag on there, but a whole thing that covers the front of the telescope. Right? Yes, it's going to be probably more expensive, but in the end, it's much safer for both your optics and potentially your eyes, right? I mean, and you could damage the telescope too. So, yeah, it's. I think there's probably a pretty big difference in cost, but I would lean towards the former, right? Getting a big thing to go on the front. Good. Yeah. Catch up to the chat slowly. Okay, so you've got both. So yeah, use the big one. Use the big one. That will do you great. That'll do you great. Um, I don't see any reason why you would want to use the small one at all. At all. Ask around though. When you go to the astronomy club, um, ask ask them because I don't have answers. I don't have answers. I just have my own experience, and so yeah, I would say ask around a little bit more. But that's just sort of my thinking, right? Is that if if you never
It's
let
just like on Star Trek Into Darkness when Captain Kirk said to Spock, "It's not logical thinking; it's just my gut feeling."
that's all. Yeah, and it's just experience and yeah, I mean a little bit of logic, right? I mean, if you don't let all that bright light in to begin with, then there isn't any kind of concern about getting too hot. So cheers to the sun.
Yeah. I like to know how long. I like to know how much for longer until the black solar probe will touch that sun.
I think they're going to start going into orbit. In fact, they already are in orbit, going around the sun now, and they're actually going to be um, making 7 orbits, um, and each one is going to get a little bit closer. And they're going to use Venus, right? They're going to go by Venus each time around to sort of fine tune their orbit. No, it's not 7 times. It's something like 4 times or something. It's about a 7 year.
I want to make sure that none of the old people go blind or blinder.
Yeah, yeah. Yeah, I would say put the front one on. Yep. So yeah, the Parker Solar Probe I think is supposed to get into its final orbit in about I want to say about 7 years or so. Hey there, Chuck. Nice to see you in the chat. I didn't say hi before, but I noticed you there.
He's also going on as Crooked Ninja 5.
Yeah,
He's getting a lot of spam on his other account.
Wow. That's no fun. That's no fun. Yeah. The H alpha for sure. That's a very very narrow band, and it sort of naturally blocks out most of the sunlight. So it acts like a filter, right? I mean, it knocks everything out except just a very very narrow band around the hydrogen alpha wavelength, which is about 68, 60 angstroms or so. Don't remember exactly. Somewhere around there. Yeah. I'm not quite sure if it's going to take 7 years to close in on the sun, or if it's 7 orbits and like 4 years, right? Is it 4 orbits in 7 years, or um, um, 7 orbits in 4 years? I don't remember exactly, but yeah, it's going to be a little while. It's going to be a little while, but flying by Venus is going to be very very cool. And then of course getting relatively close to the sun. I think they're getting something like 4 million miles from the surface. I don't know if it's from the surface or from the center. It's different. Oh yeah. That's another option too. Is solar projection, but you almost run into the same trouble with the heat, right? But yeah, that's an option to look at. But yeah, lots of different ways to safely look at the sun, for sure. Yeah, I think the sun, in terms of sunspots and everything, has been pretty low in activity here. I don't think that there's been too too many, but I think we are at a minimum, right? The sun goes through these cycles, right? Where at some times there are lots of sunspots and flares, and other times there are very few or none, and that can last for days or weeks, right? With no sunspots at all. So very cool. Cheers to the sun
Yeah.
again.
Tom Bad Discovery says it takes about 7 Venus gravity assist flybys.
Okay.
He did the issue. I melted cheap eyepieces with plastic parts that way.
Yep.
And can you explain out to what it was solar projection?
Yeah. Oh, can I? How can I do this? I wonder if the idea, Atta, is that you still are going to use your telescope, right? But instead of focusing it down to an eyepiece, what you do is you project it onto like a large piece of white poster board or something, or onto a wall or onto the ground, right? So your focus is quite different than what it would be like up at the eyepiece, right? So yeah, and then you look at the sun that way. So okay, cool. Thanks, Uncle Bill. Yeah, just Google around a little bit too, and you'll see the various ways. Now, for instance, when I observe a solar eclipse, right? Like there was one here last year, August, right? Observing that, what I did, right, is I took a pair of binoculars and set them up on a tripod, and then use projection to project an image of the sun onto like a piece of paper, right, behind the binoculars, and watch the eclipse that way, right? Because you can see the sun, and of course you can see the moon moving across it. So yeah, and super simple, super simple. The only real complication with projection, right, is that if you're I don't have my binoculars here, but if you've got a telescope, right, this sort of looks like a space telescope, and say you're looking at the sun at that angle, right? Well, you need to have your, I'm going to get this chat off of here. You need to have your piece of paper, right, sort of perpendicular to it, right? It can't be like, flat on the ground, because then the sun is going to make, sort of an oval shaped, right? Can't have it on the wall because it's also going to be misshapen. So if you want to have a round sun, right, your poster board or piece of paper has to be perpendicular to your scope, right? It's got to be like that, right? Wherever you're looking, it's got to be like that. That'll make a round sun. The cool thing too is that the further away you move, right, your piece of paper, the larger the sun will appear. And you can still, change the focus of the telescope, get that thing nice and sharp. But you can project any size you want, right? Several feet, right? I mean, if you got a big poster board and all that, it's great. It's great. So
here's Tim Robinson. What's up, Tim?
hey there, Tim. Nice to see you. Nice to see you in the chat. I've seen you chit-chatting around here and there, so nice to see you. Yeah, 3x5, perfect. You know, for simplicity's sake, right? Just a regular piece of white paper works fine too. So like Uncle Bill said, that's probably the simplest way to go on that. So cool. Cool. Cheers. So yeah, let's see the rest of the star party. I'm trying to remember. So we looked at M57, the Ring Nebula. We looked at M27, the dumbbell. We looked at M71, Messier 71, which is a cluster of stars. It's well, it's either a very rich open cluster or a very loose globular cluster, but a pretty nice cluster nonetheless. We also looked at the double cluster over in Perseus. We looked at Alberio, the binary star. It's just a visual binary star. One star is actually closer to us than the other, and they just so happen, to sort of line up, right? So they're really close to one another as we see them, but they're actually not going around each other. One's here and one's way back here.
Yeah, I want to go first class to make a good first impression of my potential star partiers. And Crooked Ninja 5 says pinhole and container works too. Well, I find no fault with a pinhole container.
Yep,
but
that works.
I usually don't. But use it for the eclipse. It's not the way to go.
Yeah, it's that isn't ideal, right? But in a pinch, that'll work. That'll work for sure. And Atta, you're on a learning curve too. So bring to them what you've got, and then next time, bring to them what you've got, and it'll probably be, better and more. And then do it again, and you'll bring a little bit more. So yeah, just I mean, if you're so inclined, just do it with the knowledge and skills that you already have. You're going to fumble around. I mean, that's all part of it. So definitely aim for doing your best, but yeah, there's always complications and there's always weird things. So last night I was trying to go after NGC 891, which is a really beautiful and pretty bright galaxy, and man, I could not find that thing at all. Now, this telescope does have the capability. It's got what's called a go-to mount, right? So I can type in the name of the object, and it'll go there, right? But I'm old school, right? I'm old school. I like to find these objects myself, because that's for me, that is sort of part of the whole experience, right? I mean, really, if I want to just look at an object, there's a lot easier ways of doing that, right? I could come inside, get onto the computer, and look at pictures of all of these objects, right? Multiple pictures, right? So, but part of the fun for me, at least, is the hunt, right? Is actually trying to find these objects. So, it's definitely not fun being a participant in a star party when you're just sort of standing around waiting, right? So you know, if I can't find an object pretty much right away, I'm going to move on, right? You know, because I don't want everybody, you know, standing around, right, waiting or anything like that. Um, so, but with this guy, it's like, you know what? I really want to see this because I haven't seen it in quite a while. Fraser Kane, he looked at it the other night through his scope, and it's like, oh yeah, 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 that's a nice looking galaxy, right? And man, I could not find it, and it makes me mad because you know, you know, I can find things in the sky usually, but man, this thing was just not giving me any satisfaction whatsoever. So yeah, I mean, you know, I gave it a good try, and you know, the 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 energy level of the star party, right, went from this, right, and then I started to look for this object, and the energy went down and down and down and down and down and down and down till it was like really, really low, right? People started to leave, and it's like, you know, everybody was worn out at that point. So we looked at one final object, Albireo, and called it a night. But it was like 2.5 or 3 hours or so. So it was pretty fun. It was pretty fun. And you're exactly right, Atta. The pointing, at least with this scope, right? And most scopes, the pointing isn't all that accurate either. It can sort of get you in the ballpark, but you usually have to do, you know, the fine tuning anyway. So yeah, and as I said, I'm old school, so I like to find all these things. All right, well, cool. All right. So yeah, it was a fun time. I think everybody enjoyed themselves. The you know, what I sort of wait for and anticipate is the oh wows, right? And there were a lot of oh wows. So you know, I think at least a few people had never looked through a telescope before. So you know, they don't know what to expect, right? They have absolutely no idea whatsoever. And you know, when it's focused up on Saturn, and if they see that for the first time, you know, it's a pretty intense experience, and you know, not only for them but for me as well, because it's like this is the first time, right? And first times are special. Hopefully, it won't be the last time. Cheers. All right, well, cool. Let's see. What are we inclined to do here? We have a little bit more time, or we can have a little bit more time. We can go short tonight too. No problem with that. But yeah, you know, I'd like to think astronomy as much as I possibly can. So yeah. So Tim, you've never looked through a scope. Okay. Well, if you're so inclined, there are very, very, very active groups over in the UK, everywhere. So you know, if you're so inclined, try to hook up with one of the amateur groups, and having a. So I'm going to mute that. There we go. So yeah, you know, hook up with a group there, and you know, you don't have to be a member to go to a star party. of course, especially if it's a public one, right? I mean, if it's a public one, you just have to find out when and where. And start parties are great because, you know, usually there are several telescopes, right? And you can actually ask them, you know, as you move along, you can ask them to look at the same object through, you know, a bunch of different telescopes, and you can sort of compare and see, you know, what the differences are between, you know, a small refractor, large refractor, small reflectors, big reflectors, different kinds of telescopes. It's kind of neat to do that, and yeah, there's a very active astronomical community there in the UK. You just have to look around a little bit. I'll bet that you may even already know, may already even know that. So cool. Yeah, you know, and that's kind of the cool thing about start parties too, is that you know, they go as long as they go. So, you know, don't wear yourself out, right? I mean, my thing is you know, I'll do it as long as people want to be there. When they're like, well, you know, I need to go, then it's like, okay, well, I need to wrap this up, right? So, but yeah, it was fun, successful. I may actually do it again. I may actually do it again in another week or so, because for some reason, you know, this happens, right? This happens. For some reason, I thought that this yesterday was actually a week from now, because I would have liked to have the moon there too. We didn't have any moon, which, you know, has its own advantages, right? Because it provides for a little bit darker sky. But I definitely wanted to show folks the moon, and we just couldn't. We couldn't. So next week it'll be up in the early evening, and we'll be able to see it. So yeah, there's another possibility. It's very slight at this point. I would say right now there's a 10, maybe a 10% chance that I'm going to do that again. But I've got a week to think about it, so that may change. That may change. Binoculars, yeah. So yeah, there's a possibility that I'll cancel another one of these just to do another star party. All right. Well, you know what? I think I'm going to cut this a little bit short tonight. You know, just talking and thinking astronomy for a while is so fantastic. It's so much fun, and it's so great, you know, that all of you come in here and share this passion, because that's all it is. And it's a curiosity, right? It's like an insatiable curiosity. What is this? What's it about? What's it made of? How does it go? What does it look like? What does it do? You know, just tons of questions, right? So, but that's what science is all about. That's what it's all about. All right, you guys. Well, as I said, I think I'm going to cut this a little bit short tonight, just talking about the star party. Look for star parties in your area, right? I mean, they're happening practically all the time. And you should be able to find, you know, more than one in your town or your county or your parish, right? So yeah, take a look around, see if you can find any local astronomy clubs, and because they're usually very active. They like new members, and they like to talk astronomy almost as much as I do. Almost. All right, you guys. Well, hey there, Tech. I see you in the chat. Nice to see you. Unfortunately, I think I'm about to exit these waters for today. So I do this practically every single day, starting at 2 hours UTC. So that was about an hour ago or so. Well, if I knew how to grow a YouTube channel, I would be doing that. I think the and I've talked about this here. I think the most important thing is consistency. Consistency, and be authentic. Do what you like to do. Show what you like to show, but yeah, I think the most important thing is consistency, right? If you're going to do something every week, then do it every week, right? No questions asked. Once in a while, okay, right? But you got to be consistent. Now, what I'm doing here is daily, right? Every single day. And at the same time, more or less the same place. Sometimes I take it outside, but most of the time it's here. And so, yeah, look, Tech, you have more subscribers than I do. So cool. Good on you. But yeah, that's sort of what I've learned is consistency. All right, Crystal, you're coming in right at the end too. Sorry about that. Nice to see you in the chat though. Very, very cool. All right, I'm going to get out of here. So I will see you all in one spin of this earth, one spin around. If you haven't subscribed yet, make sure to do so. Hit the thumbs up if you so desire, or the thumbs down. Make some comments and spread the word. Spread the word, right? I'm trying to grow a community here for sure. My intent is to share a passion, and I have a lot of passion to share. So the more I can share with, I think the more awesome it's going to be. So, all right. Well, I'm going to get out of here for now. So take care, everybody, and I will see you in 23 hours and 2 minutes. All right. Take care, everybody. Bye.
Later.